So in the second video on AS statistics, we'll be going through the key terminology and the range of sampling methods that you not only need to know, understand, but also know how to carry out. So before we get started, let's have a look at some of the terminology that you're expected to learn and understand in this particular topic. So a sample typically provides a set of data values of a random sample drawn from all such possible values. This set is called the parent population, or often just called the population. The parent population can be finite, such as all professional golf players, or an infinite, for example, the points where a dart can land on a dartboard. A sample is intended to give information about the parent population, so it must be representative of it. And that's the key thing, is that whenever your sample needs to be like a more smaller, condensed version of the general population. So parent population is usually described of its parameters, such as its mean, and sometimes this can be notated using Greek letters such as mu. So a list or other representations of items available to be sampled is what we call the sampling frame. This could, for example, be a list of sheep in a flock, or a map marked with a grid, or an electoral register. In many situations, no sampling frame exists, nor is it possible to devise one. So, for example, if you're looking at a particular fish in a particular ocean, you physically can't do it. Now, the proportion of the available items that are actually sampled is what we call the sampling fraction. So this is where you are taking a particular part of the general population as the population. So if, let's say, you were looking at a particular fish in part of an ocean, you would say, right, the population I'm going to be using is this section of the Pacific Ocean, let's say. So that would be, so where your population is not the general population, but is too big to be a sample, we can class that as being a sampling fraction. Now, there are some certain points that we need to consider. So there are several reasons why you might wish to take a sample, including the following. And that is to obtain information as part of a pilot study, to inform a proposed investigation, to estimate the values of the parameters of the parent population, and also to conduct a hypothesis test. So we take a sample when it's not possible for us to use the whole population. Obviously, to make your results incredibly accurate, or to get the most accurate sort of conclusions, you need to ask everyone or to test everything that's potentially there. And there are several points to think about. So first, you should consider how the sample is to be collected and what steps you can take to ensure its quality. Now, an estimate of the parameter derived from the sample data will generally differ from its true value. So when you are, let's say I want to take out a sample of test scores in a particular year group. So if I was to talk about the difference is called the sampling error. So if I was to work out the mean test scores of my sample, and I then was able to work out the test score mean from the whole of that year group, then the difference is what we call the sampling error. And what you tend to find is that the mean of your sample tends to be bigger than the mean of the population, because you kind of allow for this sampling error. You allow like a margin of error of where you would need to be. So for example, if I was to go to let's say a party, let's say a 16-year-old birthday, and let's say I would say the average age of people at that party would be roughly around about 16, because you would expect there to be more friends of the person who's 16 than there are other relatives. However, if I was to actually work out the average age of that, then again it's going to be expected a little bit higher. So what I might do to my sample mean is, maybe if I was to guess, is maybe increase a few years with the anticipation of there being adults there to supervise the people that are there. So to reduce the sampling error, you want your sample to be representative of the parent population as you can make it. However, this is easier said than done. So in an ideal situation, you want your sample to be a perfect representation of the population, because obviously then you can then draw similar results as you would have done had you worked with the entire population. So just before you carry out a sample, you need to ask yourself the following question. is the data relevant? So it is a common mistake to replace what you need to measure by something else for which the data could be more easily obtained. So make sure that the data you're collecting is relevant to what you think rather than what is just simply convenient. So you need to ensure that the data you're collecting is going to be relevant given the values of whatever it is that you really want to measure. Next part is the data likely to be biased? So bias is a systematic error. So if, for example, you wish to estimate the mean time of young women running 100 meters and did so by timing the women members of a hockey team over that distance, your result will be biased, because what you'd expect is that women in a hockey team would be fitter, more athletic than the general population of young women. So you would estimate for a time that your estimate for that time would be a little bit lower. So you must try and avoid bias in your selection of your sample. The next thing to consider is, does the method of collection distort the data? So the process of collecting data must not interfere with the data. That is, for example, very easy when designing a questionnaire to frame your questions in such a way to lead people into making certain responses. So things like biased questions like, are you a law-abiding citizen, or do you consider your driving to be above average, are both questions inviting the answer to be yes. So in the case of collecting information on voting intentions, another problem arises. So where people put a cross on their ballot paper is secret, so people are being asked to give away private information. So it's like personal information. So you want to make sure that the questions that you're asking or the method of collection doesn't make your data more biased towards a particular response. The next thing you also need to consider is the right person collecting the data? So bias can be introduced by the choice of those taking the sample. So for example, the school authorities might want to estimate the proportion of students who smoke, or vape in this case, which is against the school rules. Each class teacher is told to ask 5 students whether they smoke, so you're expecting all students to say no to their teacher in fear of getting in trouble if they say otherwise. Even though, however, if you asked a student of their similar age that question, and you know that the data is not going to go anywhere, or it's going to be sort of anonymous, then they're more likely to give you a honest answer. The next thing to think about is the sample large enough? So a sample must be of a sufficient size for the results to have some meaning. And so if, like example, now generally speaking, the smallest sample you can probably have is going to be 30, and that kind of explained in sort of year 2 when we're looking at normal distributions. However, you need to make sure that your sample size is a decent representation. So usually rule of thumb is, I would say, and this is just my personal opinion, I would say usually about 30%, but you want to make sure that you're getting a range of results so that your data cannot then be criticised or your conclusions not made invalid purely based on the number of or the type of people that you have been asked. So if a sample has been well chosen, it will be the case of that the larger it is, the more accurate will be the information it gives about the population, and so the smaller, and therefore the smaller the sampling error. The sample size you choose will depend on the precision that you need. So again, it depends on whether you want your reliability to be within 1% or 5% in terms of its accuracy. And again, this kind of leads into significance levels, which when we move on to hypothesis testing will come more into play. And then finally, is the sampling procedure appropriate in the circumstances? So the method of choosing a sample must be appropriate. So there are several sampling techniques that you need to be thinking about, and there are going to be certain situations where one sampling method is going to be better than another. Now, each sampling method has got its advantages and disadvantages, which is what we're going to move on to next, and discussing each of those sampling methods. And for you, it is important that you're able to, 1, know what the sampling method is, what it entails, how to go about collecting the data, what potential problems you have, and also the advantages and disadvantages of using that sampling method. So when talking about sampling, it's important that we understand some of the key words that are involved in this particular topic of statistics. So collecting a sample can be incredibly useful when an entire population cannot be used. Now that word population, now in a statistical inquiry you often need information about a particular group. This group is known as a population, or a target population as sometimes it's called, and it could be small, it could be large, it could be infinite. note that the word population does not necessarily mean people as well. Here are some examples of population. So you could have pupils in a class, you could have people in a country in full-time employment, you could have hospitals in a particular region or county, you could have cans of soft drink produced in a factory, types of trees in a wood, or even rational numbers from 0 to 10. Now, when we talk about samples, so sample is a representation or a subset of that population. So when selecting a sample, it's important that you consider the following. So how big of a sample are you wanting? So obviously if you've got a sample size, population size of 100, you're wanting a sample size that is not only a good representation of the population, but also easy for you to contain. Obviously in an ideal situation you would be using the entire population, but when that's not feasible, a sample is needed. So you're wanting a decent size sample, and involved in other topics in statistics, there is a set sample size, a minimum sample size that you are going to be needing. Now the location, time, cost and convenience of collecting a sample of this size is also going to be important as well, because obviously in an ideal situation you want your sample to be as big as possible, but sometimes that's not going to be feasible with regards to location, the time it's going to take for you to collect this sample, the cost of collecting this sample, and the convenience of doing it as well. Because obviously when you have got a hypothesis that you want to investigate, you might be under a certain time constraint to get that completed. Now, one of the most important things that we move on to is biasness, so potential bias in the data collection sample process. Now, the purpose of sampling is to gain information about the whole population by selecting a sample from that population. You want the sample to be representative of the population, so that you must give every member in the population an equal chance of being included in the sample, and this should eliminate any bias in the selection of the sample. Now, sources of bias include the lack of good sampling frame, so using a telephone direction misses all those who do not have a telephone or those whose number is X directory. Using electoral register in a city misses more mobile section of the population. So the wrong choice of sampling method could also have an impact on that, so choosing an individual rather than a particular group such as a household. There's also non-response by some chosen units as well, so it might be difficult to locate a particular sort of group. The cooperation of a respondent might also not be obtained, so if you've ever been into town and you've got people with clipboards and you think, oh, they're asking me for money or asking for me information, and you just want to get on with your shopping, you might kind of avoid doing that. So there is that element of awkwardness when it comes to cooperation as well, and also you get these market researchers who end up ringing you and you think, well, I haven't got time for that. So the inquiry might not be understood. So for example, the questionnaire might have been badly designed or badly worded. So questionnaires need to be clear, specific, ambiguous and easily understood. Questions need to be worded neutrally, especially in opinion surveys, to avoid bias caused by pointing towards a particular response. And bias introduced by the person conducting the survey as well. So an interviewer might not question someone who appears uncooperative. The style of questioning might influence the response. So it should be noted that in a sample can only be representative of the population from which it is selected. If you select a sample of teachers from one school, the sample is representative of the teachers in that school, not all teachers at all schools. So in terms of sampling methods, there are several sampling methods that you can use to collect a sample. Each method has its own pros and cons, and one may be better suited to the data or the type of data that you wish to collect. So there are random and non-random sampling methods. So in the statistical unit, you should be able to, one, be able to describe a method and know the differences between each method. So understanding the difference between random methods and non-random methods and the differences between each of those subgroups. You also need to be able to recall a method's advantage and disadvantage. So in a sort of exam question, you might get asked to criticise the use of a method that someone has decided to choose, or its advantage of choosing that and why it's probably beneficial for that particular set of data. And also you need to be able to have a step-by-step method on how to collect the data using the sample method, including identifying any potential problems and how you would correct these. So if you were to get a sample method question in an exam paper, it would probably be worth about potentially 3 or 4 marks, in which you'd have to give a step-by-step sort of method of how that data is to be collected, and also identifying something that could easily go wrong and how you'd go about correcting that issue. So moving on to random sampling. So the first one we're going to look at is simple random sampling, which is abbreviated as SRS. So it's known as a probability sampling, and as each member of the population has the same chance of being selected. Each member is assigned a unique number and then selected by selecting a number at random using a random number tables or a random number generator from a calculator or a computer or a raffle. So you can either use Excel and use a random number generator, or you can use a random function on your calculator. Now if you have your calculator handy, one thing you might want to type in is, if you were to press if you go into normal calculation mode, if you press shift, and you should have a ran hashtag somewhere on your calculator shift function. So if you were to press, and I've just got one of the Casio calculators, if you press shift and the decimal point, a ran hashtag comes up. Now if I times that by 100 and then press equals, I might have to press the sort of fractions decimal button, and if I keep pressing equals, what it will do is it will give me a random number between 1 and 100. So if I was to assign, let's say if I had 100 people in my population, I gave them all a number, and what I would do is use my calculator, I would use the random number generator on that to generate and call out each of those numbers. Now, one of the advantages of doing this is the numbers are truly random and free from bias, because obviously I'm just picking numbers out of a hat, let's say, or in this case using a calculator or a computer. It's going to be free from bias. It's also very easy to use. Each number has a known equal chance of being selected. It's very cheap and not very time consuming. Now the disadvantage of this is that it's not suitable when the sample size is large. If you imagine that I'm going to try and collect a sample of, let's say, a school that's got 3,000 students, assigning them with a number can be quite difficult. Now obviously school's probably a bad example because they probably have a register, probably have all their names on the system, but if you look about other situations, it might not be feasible. And also, when you are selecting things randomly, it might not necessarily be a good representation of data which involves many subgroups. So for example, if I'm wanting to do a survey on whether soft drinks are whether fizzy soft drinks are sold at school, if I was to, let's say, do a sample of, let's say, 3,000 students, and I picked a random sample of 30 students, you might find that the people that I've selected don't drink fizzy drinks. So I'll only know that until I've actually asked them the question. So there's certain groups that are disadvantaged by this, in fact, that depending on the data that you're wanting. This just allows you to select a random number of people, but if you wanted to go to any of the specific questions you need to ask that, it might not be viable for that particular group. So moving on to the next one. Now obviously one thing we need to look at here is the method in which you do this. So collecting a random sample, the first thing we need to do is assign each person with a number, then using a table or a calculator or computer, or even numbers in a hat, multiply the random number by the population size, and then stop until you have the sample size you require, ignoring any duplicates. Now that ignoring any duplicates is one of the problems that you might face when you are random sampling and using this random number generator. That if you do come up with a number that you've already selected, what you would then do is ignore it and move on to the next one. And it's really important that when you're describing this method, you do include that, because as I mentioned, whenever you're choosing or describing a sampling method, you always want to be able to talk about a potential issue that could go wrong and also then rectifying it. You don't want to be one of those people that's always moaning about something. You always want to have a solution for it as well. Now another method of random sampling is what we call systematic sampling. So this method takes every nth term in a population until a required size of sample is obtained. So as long as the data is not in any particular order, this method is better than simple random sampling as it is simpler. The method is used when the sample is too large for simple random sampling. So the advantage of this method is simple to use, it's suitable for large groups, cheap, and can be quick. The disadvantage is that it's only random when the data is not in a particular order. It might not be a good representation of the data. That involves many subgroups, very similar to the simple random sampling. Now, going on to, in terms of going into this a little bit of a detail, so if, let's say, I had a register of students in my class, now let's say I want to get a random sample. Now, if I will select, let's say I had a class of 30 and I want to select 6 students, so I just choose every 5th student, what that might find is that by selecting every 5th student, the person who is first, the person who is last is not going to get selected. And so in order for it to be free from bias, every student needs to have a sort of equal chance of being selected, which is not going to be the case if the original list is in a particular order. One way of getting around that is if you completely utterly randomize the data and then split every 5, everyone has an equal chance of being selected. So as an example, if I wanted 40 children in a year group, so again just going into detail of what a description would look like. So I want 40 children in a year group at a school which has 200 students, so I'd assign each person with a number, and then I'd randomise those students, either jumble them up or close my eyes or something like that, and then I'll select every 5th person until I have 40 students. So there will be no elements of duplication in this, it's just a case of working through it. Now if you were to go through duplication, let's say you had a list of, let's say 100 students, and you were to pick every 20th student, then obviously by the time you saw through you'd only have 5 students before they left. So that's one sort of criticism you could find. If you imagine that you've got an assembly taking place and you're going to stand outside and you're going to ask a question to every 5th person that exits that hall, then you need to make sure that at the end, by the time they've left, you've collected the sample size you're wanting. Otherwise, you're going to feel a bit of a numpty if you are then wanting to sample 20 people and really you've only asked 5 and the rest of them have all gone somewhere. So the next type of random sampling is what we call stratified sampling. So this is when a population is first divided into subgroups or categories before being randomly selected. This method is used when a sample is large and can be divided into mutually exclusive groups. So what this basically means is, if I go back to the whole school issue, and again I'll go through an example of this, is in a particular year group you might find that there's more of one type of person than there are others. So for example, if let's say I had a population of 100 students, 60 of them were males, 40 of them are females. If I was to select a random sample, a sample size of 10 students, then I would want the same sort of percentages of each of those groups in my sample for it to be a good representation. So if I had a sample size of 10 students, I want 6 of them being males, 4 of them being females. Now, once I've selected how many of each subgroup I want, I can then use a random sample generator or simple random sampling or a systematic sampling method to select those 6 or 4 students respectively. Now, the advantage of doing this method is that it can be more accurate estimates than random number sampling or simple random sampling when it is clear subgroups are present. You can also give separate estimates per subgroup. Now, disadvantage, same as simple random sampling, but also if the subgroups are not mutually exclusive, it cannot happen at the same time, then they can overlap. So for example, if I'm wanting groups of gender and then all of a sudden I'm wanting groups of people who wear glasses and don't wear glasses, obviously there's going to be sort of issues between those two. Can also be very time consuming to group the data before selection. So again, that's one disadvantage you may face. So going through an example, again going back to the all-trusted one, the school was to select 30 students to do a survey about Key Stage 3 and Key Stage 4. To ensure a good representation of a sample is collected, they decide to use the stratified sampling technique. So here are the official numbers of people in that school. So you've got Year 10 and Year 11, Year 12, Year 13. A bit strange there how they're not asking any Key Stage 3 classes, but I'm guessing probably looking at past data. So here we've got 235, 242, 123, 86 students in each of those year groups respectively. And as you can see, if you look at the percentages, I've got more Year 10 and Year 11 students than I have Year 12 and Year 13 students. So when I'm selecting my sample, I want to have those same percentages within that group. So if I'm having a sample size of 30 students, if I work out those percentages, I want 10 students from year 10, 11 students from year 11, 5 students from year 12, and 4 students from year 13. And then, like I said, once you've selected how many of each student, you can then either use simple random sampling or a systematic sampling method to select those 10, 11, 5, 4 students respectively. Now the next thing we move on to is non-random sampling. So the first sampling method we're going to look at is what we call cluster sampling. So in a cluster sample, subgroups are selected rather than individuals. So rather than you, let's say, pointing a finger and selecting, right, I'm going to ask you, I'm going to ask you, I'm going to ask you, you just say, right, you know what, I'm just going to ask this class. Okay, so it's not a case of looking at individuals, it's a case of choosing a group, and it's those people that you're then going to choose. The advantage of using this method is a lot more efficient than using simple random sampling, especially where a study takes place over a wide geographical region. So what it means by that is if I was to take a poll of, let's say, how a country was going to vote in the next election, rather than selecting random people, I might say, right, let's just pick this city or this town and just ask them. Might be convenient because I've got easy access to that region. It might have the fact that there's less people in terms of sample size of that region is good enough for me to pick, etc. Now, a disadvantage of this is that there is an increased risk of bias, so may not be representative of the whole population, resulting in sampling error. So for example, if I was to let's say select a city in the north, and let's say the economics have found that there's low employment in the north, then asking them about their sort of opinions on politics might be very conflicted because of how they're feeling. So whereas people in the south might have more opportunities and may feel happy about the sort of local government. So it's always worth having these advantages and disadvantages in place. So, and there are always going to be advantages and disadvantages on every sampling method. You've kind of just got to make a compromise as to which ones you're happy with and which ones you're not going to be happy with. Now, another non-random sampling method is what we call a quota sample. So this method is often used by market researchers. Interviews are given a quota of subjects of a specified type to attempt to recruit. So this is similar to a stratified sampling without the calculations. So it might be a case where a company has said, right, we want you to interview 60 women from this area on this shampoo product, and so forth. So it's where you've been given specific instructions of how many of a subgroup you're wanting. So going back to that, the year group one, it's me saying to a student, right, I only want you asking 20 year 10 students, 15 year 11 students, 5 year 13 students, and 7 year 12 students. Whereas stratified calculations, you actually finding those specific percentages and working through there. The advantage of using this is that it's relatively straightforward and representative of a subset of characteristics. So if I'm wanting to ask, let's say, a particular subgroup, I can make it so that the sample I'm selecting is going to include that. So disadvantage is not random, as each person in the population doesn't have an equal chance of being selected, and you can select what characteristics you don't want. Now the next sort of sampling method we can go for is what we call opportunity sampling. So this takes samples from members of the population you already have access to until the sample size is required. So the advantage of this is that it's cheap, easy, quick. Now, so an example of an opportunity sampling method would be, let's say a head teacher wants me to gauge an opinion of what students think about school uniform. Now for me, I've got a class next. What will be easier, rather than me going through all the faff of doing a random sampling, looking at subgroups and thinking, right, do you know what, I've got a class next, let me just ask them. In which that's where it's going to be very quick, it's going to be very easy, and in some points it's going to be very cheap as well. So a disadvantage of that, it could be biased toward, bias cannot be generalized, and researcher can control over who is selected. So for example, if I'm going to ask opinion on school uniform to a class that's going to be leaving the school next year, do they really care? Probably not. If I ask this a class that's just started the school, they might feel nervous and apprehensive about going against the system. So they might think, well, no. And also they may have just invested in a school uniform. The last thing they want to do then is end up buying a new one. So when we talk about sampling methods, just to summarise and just to finish off as we're coming up to the end here, as I go back to that first screen, it's always important you know the difference between random sampling and non-random sampling. Bias is one of the key aspects of something that you really do need to get your head around. And know the procedures of collecting a sample, its advantages, disadvantages, a potential problem that you would face when collecting that sample, and the most important, I can't emphasize this enough, how you'd go about correcting that. Now, as I mentioned, no sampling method is the best one. Some are more suited for a certain type of data collection, some are better suited for others. So it's important that you read the question carefully and get your head around these sampling methods. One way of revising sampling methods is having examples. So have an example of, in your head, of when you're revising, of what is meant by a quota sample, what is sort of described as a stratified sampling. And have that in your head. It's a lot easier to describe sampling methods when you have got an example to base it on, and it's easier for you to understand. Now, Googling is really good on this. If you Google a sampling method and you're wanting an example, there's plenty in there. Sampling methods are heavily used in other subjects as well, particularly in psychology. They have their own sampling methods, and there are loads of sampling methods you can choose. Now, in your syllabus there'll be a certain required of types of sampling methods that you need to know. So for example, there may be 30 different sampling methods, but your syllabus may only really require your knowledge in about 5 of them. So it's important that you speak to your teacher, you research your syllabus and understand which ones there may be some sampling methods that I've not mentioned on this video that you need to be aware of, so it's worth just double checking. But the whole emphasis of this is making sure that you know what the sampling method is, know how to collect it, know the advantages, know the disadvantages, pick a particular fault and know how to correct it. Now, if you're wanting a copy of this particular PowerPoint or the notes on this, feel free to drop me an email at 162maths@gmail.com.